Yes, hi, this is George Larakis again, and today I would like to discuss about how you solve problems in the topic of specific heat. As always, we start with one. You will do this. In this case, it's obvious, and when you have a problem in this topic, you have to use the formulas that we will just state right now. The formulas that you have to state here have to do with two parts. The first part is when you have a change in the temperature of the material. In this case, you have to use the formula Q is equal with Cp times M times delta T, where C is the specific heat of the material, M is the mass, and delta T is the difference in temperature, the final minus the initial. So the second formula is when the material changes state, like it can go from air to liquid to a solid and vice versa. So in this case, the formula that you have is that Q is equal with Lm, where L is the latent heat of the material and M again is the mass of the material that is changing state. We said that Cp stands for specific heat of the material, and L it's the latent heat of the material again. Now we can go and do an example. So the example here is that we have mass MC, which is a mass of a piece of copper, and we have that this is in some temperature T1, and then we take this mass of copper and we put it in a container of water with mass M water that has temperature T W, and we leave the piece of copper inside the water, and of course the T here is much greater than the temperature of the water, and we leave it until the final temperature of both the water and the copper, it's T final is equal with 100 degrees Celsius, and we leave it there until the whole system it comes to equilibrium. So, and the question that we have here is to find how much water will be evaporated. So we're looking to find the mass of the water that will be evaporated. So that's the problem, and now let's try to do the solution of this problem. So what happens here? First, so let's say a small diagram here. So let's say this is the container, and this here is the water, and let's say that you insert inside a piece of copper. So let's say this is the piece of copper. And you leave this until both of them, they are in a temperature of 100 degrees Celsius, and the whole system is in equilibrium. So what happens? First, we have that the copper, it will lose some heat Q. Why? Because the copper, it will go from some temperature T1 to some temperature T final, but it will still be in the same state. It will still be a solid. So that means that we have to use this equation here. So that means that the Q that the copper will lose, it will be C of copper, the mass that we know, which is MC, times the delta T, which will be T final, which is 100, minus T initial of the copper. So, and of course this quantity here, it will be negative because this here is a negative number. So that's why we know that this is, that's why we can confirm that this is heat which is lost. Now, what also happens, so this is the Q that the copper will lose, so let's say QL. And now let's see what happens to the water. So now the water will get some heat from the heat that the copper lost, in order to go from some temperature, which is much lower than this here, to go to this temperature here. So, but still remains water. So still is liquid. So that means that it didn't change yet exactly at 100. It starts changing the state. So the water in 100 degrees Celsius boils or evaporates. But first it has to reach this and then it evaporates. So that means that for the water, what we will have Q, let's say 1, it will be the C of water times the mass of water times the delta T. So here again, the delta T, it will be the final temperature, which is 100, minus the initial temperature of the water, which is TW. Okay, and of course this thing here, it's positive because, the 100 minus TW, it's a positive number. So that's in order for the water from the temperature TW to go to a temperature of 100 degrees Celsius. And now, once it gets to this temperature, it will start boiling, so it will start to evaporate. So that means that it's changing state. So that means that we have to use this formula here, which is when the material it changes state. So that means that some other part of this, of the heat that is released from the copper, it will go in order for the water to change state, to go from liquid to vapor. So that means that we have L, and here the L, the latent heat for vaporization of water, times the mass of the water that will evaporate, which is what we're trying to find. So, and again, of course, this is here is positive. So what happens? I mean, because this is a contained system, so that means that the energy that is lost from the copper, the heat that is lost from the copper, it will have to go to the water in order first to increase its temperature, to go from TW to 100, and then to change state. So that means that this here, it has to be equal, the QL has to be equal with Q1 plus Q2. So let's continue here. So what we have that QL, which is CM 100 minus T1 has to be equal with Q1, which is CW times MW times 100 minus TW plus LV times the mass of the water that it will evaporate. Here, we can put the minus here because we said that this here is negative, so you should put a minus in order to make it positive, because this is the absolute value of the energy that it will be transferred, so it has to be positive. So this has to be equal with this plus this, and of course here we know the MC, we know T1, we know MW, we know TW, and of course we know LV, like the latent heat of water and the specific heat of copper and water. I mean, all those are given. So, you just have to solve this equation here. So, let's finish it. We can finish it here. So, we're looking to find this. So, you just have to solve for this. So, that means that you take all this to the right hand side of the equation, and that will be C MC T1 minus 100 plus we'll bring this to the now to the left hand side of the equation. So here I wrote it like this in order to remove the minus. So we'll bring also this to the left hand side, so that should be minus CW MW 100 minus TW. Let me erase this here. So minus CW MW 100 minus TW. So from here, so if we divide with LV, if we divide all this with LV, that should give us what we are looking to find, the ME, which is the mass of water which evaporates. So that's about how to solve problems in this topic. One thing to be careful is that here the temperatures doesn't matter if they're in Celsius or in Fahrenheit, but all of them, they have to be either in Celsius or in Fahrenheit. So that's about this topic. Thank you for taking the time to view this video, and I hope you find it useful, and bye for now.